Hi students, okay, today we are learning the topic is general solution of non-homogeneous equation f of d into y is equal to q of x. When q of x is equal to, here given x into v. This is a type 5 where v is the function of x and so that is how to finding the particular integral in this type. See that here. So given equation f of d into y is equal to q of x, where q of x is equal to x into y, x into v, where f of d is a polynomial of degree n in d. So yp is equal to 1 by f of d into q of x, that is equal to 1 by f of d into xv. So direct formula here. So x into 1 by f of d into v minus f dash of d by f of d whole square into v. And f dash of d means differentiation of f of d by f of d whole square into v. V is any function, substituting it directly, finding here the previous cases and that is the previous types. Okay, now this is the particular integral of f of d into y is equal to q of x when q of x is equal to x into v. And also another method is alternate method. So here given alternate method given where x is a x power m, and x power m is only positive integer, and x square, x cube up to so on, and v is equal to here sin bx or cos bx. So that is equal to here. So this is also x place low x power m or x square x analytic same procedure, x place low x power x square x cube up to so on, or x. So I am telling only in x or x square x cube in any one choosing. Okay na. So what is the procedure is where given or particular cases v is equal to sin bx or cos bx. So that is equal to 1 by f of d into x into v. V is equal to sin bx, but we know that e power I bx in the complex number, which is can be right cos bx plus I sin bx. So cos bx is the real part of e power I bx, sin bx is the imaginary part of e power I bx. So now here in the sin bx replacing imaginary part of e power I bx, that is equal to 1 by f of d into imaginary part of e power I bx into x. So now which form here? E power ax form, e power ax into v and here proceeding case type 4 అవునా. a ప్లేస్ లో ib కదా, d ప్లేస్ లో ఏం చేయాలో d ప్లేస్ లో d ప్లస్ ib రీప్లేసింగ్. ఓకేనా, దట్ ఈస్ ఈక్వల్ టు హియర్ ఇమాజిన్ పార్ట్ ఆఫ్ e power ibx. So e power ibx is over in front of 1 by f of d. So that is d plus లో d plus a కదా, a is equal to ib. So f of 1 by d plus ib into x. Now proceeding here type 3, because this is again 1 by f of d into x power k kada. So type 3 proceeding here. So that is equal proceeding type 3. So now here how to finding it yp. So this is operating, we getting the also complex number. This is a complex number and this is a complex number. And so now protecting both complex number, we getting also a final complex number. In that result of complex number, we have to choosing only imaginary part, that is yp. Okay na, because already choosing sin bx is the imaginary part together. So last result is also taking only in the complex number, we have to taking only imaginary part, that is called yp. So similarly same procedure in case x into cos bx, v plus lo cos bx, and same procedure, but cos bx is a real part. So 1 by f of d into real part of e power ibx into x. Same procedure, k is equal to ib, in the f of d replacing d by I plus b. So real part of e power ibx into 1 by f of d plus ib into x. Now proceeding same type 3. So after this is a complex number and this is a complex number, and after final complex number you have to choosing only real part, that is the yp. So this same case applicable for when q of x is equal to x power m into sin bx or cos bx n. x place లో x power m అంటే m is equal 1 2 3 4 అంటే x sin bx, x square sin bx, x cube sin bx, the same procedure. So this is the type 3 to finding the particular integral. Okay, see the example here. Yeah, first example, d square plus 4 into y is equal to x sin x. So f of d into y is equal to q of x, where f of d is equal to d plus 4, q of x is equal to x sin x, and xv form and x into v form. Avuna? So first finding the auxiliary equation, taking the roots, m is equal to plus or minus 2y. Therefore complementary function c1 cos 2x plus c2 sin 2x. That is particular integral yp is equal to 1 by f of d into q of x. So that is equal to 1 by d square plus 4 into x sin x. That is equal to xv form. What is the formula? 1 by f of d into xv is equal to x into 1 by f of d into v minus f dash of d by f of d whole square into v. So v is equal to sin x, replacing x into 1 by d square plus 4 into sin x minus f dash of d kada. And f of d square plus 4 whole dash, the derivative finding. So d square plus 4 whole square into sin x. That is equal to a sin bx form kada, b is equal to 1, replacing d square by minus b square. Here is same sin bx. Using type 2, that is equal to x into 1 by minus 1 square plus 4 into sin x minus d square plus 4 dash into derivative of d square 2d. Derivative of 4 0, that is 2d. By here d square plus minus 1 square, that is equal to minus 1 square plus 4 whole square. So that is equal to 1 by 3 x sin x minus, so 2 by 9 d sin x, derivative of sin x. So 1 by 3 x into sin x minus 2 by 9 into cos x. So that is a yp, 1 by 3 into 3 x sin x minus 2 cos x. So therefore general solution is yc plus yp. So this is the type 5. Okay, see the next example here. So d square plus 2d plus 1 into y is equal to x cos x. This is f of d into y is equal to q of x. Now finding the complementary function, m square plus 2m plus 1 is equal to 0. So m is equal to minus 1 comma minus 1, real and equal loads. So c1 plus c2x into e power minus x. So yp is equal to 1 by f of d into q of x. So that is equal to 1 by d square plus 2d plus 1 into x cos x. Which form here? X into v form andi. Avuna? V is equal to cos x here. So using this formula, so that is equal to here x into 1 by f of d into 1 by d square plus 2d plus 1 into v. V is equal to cos x. So next to d square plus 2d plus 1 whole dash, derivative finding d square plus 2d plus 1 whole square into cos x. So which form here? Cos bx form kada. B is equal to 1 here. Proceeding type 2. Here cos bx, b is equal to 1. D square plus minus 1 square replacing. So that is equal to here x into 1 by minus 1 square plus 2d plus 1 minus d square plus 2d plus 1 ki derivative 2d plus 2 by d square plus minus 1 replacing. That is equal to here x into 1 by 1 cancel, 1 by 2d into cos x, 2d by 1 cancel, 2d whole square into 4d square into cos x. So that is equal again, b is equal cos bx, b is equal 1, d square plus minus 1 square. This is a 1 by d. 1 by d means integration. X by 2 into integration of cos x dx minus 2d plus 1 by d square plus minus 1 square into cos x. X by 2 into integration of cos x sin x. So 1 by 2, 2 common, 2 by 4, 1 by 2 d cos x plus cos x. That is equal to yp is equal to x by 2 into sin x plus 1 by 2 into minus sin x plus cos x. This is the yp. Therefore general solution is adding yc plus yp. Okay, see the next example. d square minus 1 into y is equal to x sin x plus x square e power x. So given f of d into y is equal to q of x, and now first finding the complementary function, take the auxiliary equation. M square minus 1 is equal to 0, m is equal to plus or minus 1. 1 minus 1 real and distinct roots, so that is complementary function c1 into e power x plus c2 into e power minus x. So now finding yp, 1 by d square minus 1 into x sin x plus x square e power x, the sum of the two functions here. So this is a separate case, this is a separate case. So 1 by d square minus 1 into x sin x plus 1 by d square minus 1 into e power x x square. Now separating finding, both values separating finding. First one, 1 by d square minus 1 into x sin x is equal to which form? X into v form. V is equal to sin x here. X into 1 by d square minus 1 into sin x minus, this is f dash of d, d square minus 1 whole dash by f of d whole square, d minus 1 whole square into sin x. Here same procedure, sin bx form, b is equal to 1, here b is equal to 1. Replacing d square by minus 1 square. X into 1 by minus 1 square minus 1 into sin x minus 2d by minus 1 square minus 1 whole square sin x. That is x by minus 1 by 2 sin x minus 2d by 4. So into sin x. So d sin x means derivative of sin x. So that is minus x by 2 sin x minus 1 by 2 into cos x. This is the first term value. Similarly second term. So 1 by d square minus 1 into e power x x square, which form here? E power ax into v form. A is equal to 1. Type 4 procedure. So replacing d by d plus 1 in f of d, that is e power x into 1 by d plus 1 whole square minus 1 into x square. Simplification is e power x into 1 by d square plus 2d into x square. So which form here? X power k form, and x power k is type 3. So this is f of d can be write 1 plus or minus phi of d. So lowest degree term common, lowest degree is 2d. So e power x into 1 by 2d common, 1 plus d by 2 x square. Take the numerator, e power x into 1 by 2d into 1 plus d by 2 whole power minus 1. Now this is expand, 1 plus x power minus 1. Okay na? Up to choosing d term, only d square, but x square kada. Expansion up to choosing d square. So now continuation. So e power x into 1 by 2d into 1 minus d by 2 plus d square by 4 by expansion. Now multiplying with x square, e power x by 2, 1 by d into x square minus 1 by 2 into dx square plus 1 by 4 into d square x square. So e power x by 2 into 1 by t, x square, derivative of x square 2, 2x, 2 cancel x plus d square x square means 2, that is 1 by 2. So therefore 1 by d means the integration. E power x by 2 into integration of x square minus x plus 1 by 2 into dx. So that is equal to e power x by 2 integration of x square x cube by 3 integration of x square by 2 plus 1 by 2 integration of 1 x. So this is the yp. Take the LCM. So now adding both in the equation 2. From equation 2 adding both particular integrals. So this is the total yp. So therefore general solution adding both y is equal to yc plus yp. So this is the solution of the given equation. Next example here. So solve d square minus 1 into y is equal to x square cos x. So which form here? X power m into q of x. That is q of x is equal to x square into v kada. Ante cos bx form here. So using another method of type 5. First of all finding the complementary function. So m square minus 1 is equal to 0. What is the roots here? M is equal to plus or minus 1. yc is equal to c1 e power x plus c2 e power minus x. Now finding yp, 1 by f of d into q of x. So that is equal to 1 by d square minus 1 into x square cos x. But here x into v form the lengthy procedure and now using here alternate method x square into v kada. So cos x is a real part of e power x. E power ix here, b is equal to 1. So cos x is the real part of e power ix. So replacing that one, so we know that e power ix is equal to cos x plus I sin x. But here only cos x means real part of e power x. So that is equal to 1 by d square minus 1 into x square real part of e power ix. So that is equal to real part of 1 by d square minus 1 into e power ax into x square. So which form here? Again 1 by f of d into e power ax into v. Type 4 and a is equal to I. Now replacing in f of d by d plus I. So that is equal to here. So replacing real part of e power ax into 1 by d plus I whole square minus 1 into x square. So now procedure continue. So real part of e power ax into 1 by simplification is d square plus 2id minus 2 into x square. So which form here? Again 1 by f of d. 1 by f of d into x power k. So using type 3. So take out the lowest degree term minus 2. Minus 2 is the common. So real part of e power x by minus 2 into minus common 1 minus d square plus 2id by 2 into x square. Take the numerator real part of e power ix into minus 1 by 2 into this expansion 1 minus x power minus 1 kada. So that is equal to real part of expand here 1 plus x 1 plus d square plus 2id by 2 plus d square plus 2id by 2 whole square plus up to so on. So up to choosing only up to d square term only because x square kada. So that is equal to minus 1 by 2 real part of e power ix into 1 plus d square by 2 plus id minus d square into x square. So that is minus 1 by 2 real part of e power x multiplication is x square plus. So this is id x square. This is minus 1 by 2 d square x square. So minus 1 by 2 real part of e power x into x square plus 2 ix minus 1. So this is one of the yp and so now your simplification is this is a separating, this is a complex number, this is a complex number. The separating complex number multiplying both. Okay. So that is equal to continuation. So minus 1 by 2 into real part of, so e power x can be right cos x plus I sin x. So this is a real part plus imaginary part. Now multiplying both, we have to choosing only real part. And a cos x x square minus 1 cos x into I2x I sin x x square minus 1 I sin x I2x both are all multiplying. So after multiplying the complex number, we have to choosing only real part. So that is equal to here minus 1 by 2 real part of, so multiplying here x square minus 1 into cos x plus I 2x cos x plus I into x square minus 1 sin x minus and I into I square minus 1 2x sin x. Observing here only real part we are choosing. So this is a real part and this is a real part. So both imagined part we cannot taking. Okay na. So only real part we have to choosing minus 1 by 2 into x square minus 1 into cos x minus 2x into sin x. This is the required particular integral of the given equation. So real part is only choosing the real part only, but does not taking imaginary part because cos x is a real part. So this is the yp. Simplification is 1 by 2 into 1 minus x square cos x plus x sin x. So therefore general solution yc plus yp. So this is a required general solution. Okay. Yeah, next one of the example here. D square minus 2d plus 1 into y is equal to x into e power x sin x. So given f of d into y is equal to q of x, where f of d is equal to here, q of x is equal to x e power x sin x. So take the auxiliary equation, m square minus 2m plus 1 is equal to 0. So m is equal 1 comma 1. So yc is equal to c1 plus c2x e power x. So now finding particular integral 1 by f of d into q of x, that is equal 1 by d square minus 2d plus 1 into x into e power x sin x. Observing here the product of the three terms together. So we have to choosing x into v, no problem, but lengthy procedure. First eliminating e power x, which is the converted e power ax into v and using the type 4 first of all, but easy getting the solution. So that is equal, which is can be right, e power x into x sin x, and which form e power ax into v. A is equal to 1, in the f of d replacing d by d plus 1. So that is equal to e power x into 1 by d plus 1, d plus 1 minus 1 whole square into x sin x. Now simplification is e power x into 1 by d square x sin x, that is equal to x into v, which form here type 5. So x into 1 by f of d into sin x here, 1 by d square into sin x minus f dash of d square whole dash by f of d whole square, d square whole square into v is the sin x. So here b is equal to 1, so d square plus minus 1 square, e power x into 1 by minus 1 square into sin x, d square derivative 2d, so this is minus 1 square whole square into sin x. So that is equal to simplification is e power x into minus x sin x, this is a minus 2d sin x, d sin x means derivative of sin x. So e power minus e power x into x sin x plus 2 cos x. So this is the yp. Therefore general solution is adding yc plus yp. This is the solution of the given equation. Okay. Okay. So this is the type 5. When q of x is equal to x into v, then finding particular integral. So thank you. For more videos, please do subscribe my channel, like and share it. Thank you.